We're going to look now at the correlation of the investment assumptions in this portfolio model. So previously we had defined the model, and because we're using geometric Brownian motion, we have 4 standard normal random variable assumptions. But these investments are correlated, so we need to correlate these assumptions according to the correlation matrix that's on the rows 2 to 5 of this worksheet. So here's what we're going to do. We're going to highlight the 4 standard normal distributions. I'm going to go up to correlation, and we're going to click on define correlation matrix. All right, so the inputs are specified. And so we'll click OK. And what comes up is a new correlation matrix. And so we'll go ahead and just give that another name. We'll call it Portfolio Correlations. And we'll give it a location, and we'll just give it a blank cell out here, say H1. And we'll go ahead and click OK. And you see over here, it's created this correlation matrix out here in Excel. So these assumptions are going to be correlated according to this matrix here. And so what we'll do is we'll just take these correlations. Notice this matrix here is the same size as this one here, and we'll copy them. And then we'll right click and we'll paste, and we'll paste the values just to make sure there's no formulas. Okay, so now we have the correlations. Now what's happening in the background then is these standard normal random variables are going to be correlated with these values over in the matrix. So now what we'll do is we'll go ahead and simulate the portfolio value. And so everything's set up. We've got here an output for the portfolio value. And so we'll click simulate. And so we have our distribution for the ending value. And we notice that the mean is 10,880. And we can look at things like the certainty interval. So a 90% certainty interval is from 9285 up to 12785. We have percentiles that we can use to describe the portfolio. And we can also use statistics like value at risk and conditional value at risk. And so just to illustrate here for the moment the difference between a certainty interval and a confidence interval, the certainty interval 90% states that 90% of the simulated values are between 9285 and 12785. So let's put that out here, 90% certainty. So certainly there's a 5% chance that the ending value of this portfolio is above 12,785, a 5% chance it's below 92.85. What about, though, a 90% confidence interval for the mean? This is a completely different type of measurement. So what we would do up here, where it says 90% CI, that's the half width of the confidence interval. So to get the lower limit, we'd take 10,880.04, which is the mean, and then subtract 5568. And then to get the upper limit, we'd take 10,880.04, and then add the 5568, which is the half width of the confidence interval. And so this measures how closely we've estimated the mean. So the interpretation is that if we were to repeat this simulation 100 times, then 90% of the time, the mean of those simulations would be between these values. So that's an important measure for the investor as a long-run average. The certainty interval is important in terms of understanding the variability in this portfolio.